Hey folks, what we're going to be looking at today is we're going to be looking at unit vectors, and this is a real short conversation. A vector of magnitude 1 is called a unit vector, and they're very handy for doing things like multivariable calculus, for working in linear algebra, for physics, anything where you're going to be utilizing vectors. And so we can turn any vector into a unit vector, and this process is going to be called unitizing or normalizing. And so here's the basic concept. We're going to have two vectors, they're scalar multiple of each other. That means that they actually end up being in the same direction. And that's the definition of being in the same direction when we think about vectors. Now what we're going to do is if we multiply the vector u by 1 over the magnitude of u, then that's going to transform our vector into a vector of length 1 in the same direction because it's just a scalar multiple of u. So let's say, for example, that what we have here is this. We have let's say that A is equal to 1 over the magnitude of u. And let's say that we have a vector, and our vector of u is the vector xyz. Now, the magnitude of u is equal to the square root of x squared plus y squared plus z squared. What I'm going to do is I'm going to multiply A times x, y, z. And that's going to give me ax, ay, az. The magnitude of this vector, the new vector, okay, is then going to equal the square root of a squared x squared plus a squared y squared plus a squared z squared. I can factor out a squared, and I'm going to get the square root of a squared times x squared plus y squared plus z squared. And that equals then, pulling out the a, I'm going to get a times the square root of x squared plus y squared plus z squared. Well, if we look at here, a is just equal to 1 over the square root of x squared plus y squared plus z squared. And then we'll multiply that by x squared plus y squared plus z squared. And what we get now is we get a magnitude of 1 for a times u. What we notice, take a look here, this is a scalar multiple of our original vector u, and it now has a length of 1. So the unit vector for u is going to be 1 over the magnitude of u times u. Let's do a little example. So let's transform this vector. We're going to normalize it into a unit vector. So we've got v is equal to 3, 1, negative 2. So I'm going to figure out what the magnitude of v is. And that's going to end up equaling the square root of 3 squared plus 1 squared plus negative 2 squared. And that's 9 plus 1 plus 4, which equals the square root of 14. So my unit vector, call my unit vector u in this case, is now going to equal 1 over the square root of 14 times the vector 3, 1, negative 2. And so what we do is we'll rewrite that as 3 over the square root of 14, 1 over the square root of 14, and negative 2 over the square root of 14. And that's our unit vector. Let's do it one more time. Now let's unitize 2i minus 3j. Let's think about this vector in 2 space. So that vector now is 2, negative 3 for u. And what we'll do is we'll find the magnitude of u. And that's going to equal the square root of 2 squared plus negative 3 squared. And that's equal to the square root of 13. We'll now multiply that by u. So we're going to take 1 over the square root of 13 times the square root, or excuse me, times 2, negative 3. And that then is 2 over root 13 and negative 3 over root 13. And that is our unit vector. So finding a unit vector is actually quite simple. All you've got to do is find the magnitude of the original vector and then multiply that vector by the scalar 1 over its magnitude. All right? Basically what we're going to do is we're going to divide each one of the components by that magnitude. That's what's going to end up happening. And what you'll get as a result of that is a vector in the same direction with now a length of 1. I hope you enjoyed the video. I hope you got a lot out of it and it answered your questions. So if you did, go ahead and click like and subscribe. Subscribe to the channel. You get a lot more math and we'll have a lot more fun.